Welcome to the project demonstration of battery management system along with fire protection and IoT ThinkSpeak cloud storage. So in this version we have added the feature which will store the data from this voltage, current and temperature along with SOC, SOH calculations that will be stored into the ThinkSpeak cloud platform, and that data can be accessed from anywhere in the world. So this is data which we have received while we testing of the project, and this data can be accessed from anywhere in the world as we are uploading the data to ThinkSpeak with the help of this ESP8266 Wi-Fi module. So the main application of this project is, so when we are driving an EV vehicle, there the battery will be presented and we need to continuously monitor the health of the battery pack. So the health parameters of a battery pack will come under voltage, current, temperature of the battery pack along with status, nothing but state of charging, that is SOC, state of health, that is SOH. So these are the main parameters we should consider for the battery pack. So in order to maintain the proper battery life and also safety and security for this EV vehicle from the battery pack. So here to achieve these features, we are making use of this battery pack of 12 volt battery pack, so which is a 2000 mAh. So in this we can see the 3 cells presented which are connected in series. So we will get 11.1 volt, maximum of 12 volts will be getting from this battery pack. The ampere rating is 2000 mAh, and this can be rechargeable battery pack. So that will be recharged through the 2 relays. The first phase is charging for the battery pack with the help of the 2 relays, and when the battery voltage is low, then we'll get the audible alert to the buzzer. There we can select the faster charging or normal charging with the help of these 2 switches, and that is used to control these 2 relays, and that will be allow the power supply from this charging circuit to the battery pack. And while we charging of the battery pack, we should measure the voltage from this battery pack. So that will be measured with the help of a voltage sensor. So here we are using this voltage sensor which is continuously measuring the presented voltage in this battery pack. So when the voltage is above 12.5, then automatically the system will have this electromagnetic relays to block the overcharging protection for the batteries. Same manner. So here we are representing this DC motor as an electrical vehicle, and when we on this with the help of the switch, the so-called current consumption by this DC motor, means the current was on this battery pack will be calculated by this microcontroller along with a temperature from this temperature sensor. Means whenever we are charging a battery pack, so if the battery is heat up due to the overcharging or any like a short circuit occurred inside that, or while we applied the load, if a zero overcurrent occurred on the battery pack, then there is chance of battery pack getting heat up before getting into the fire accident. So that will be measured by this temperature sensor continuously, and all these parameters displayed on the 16:2 LCD screen. And the temperature is crosses 45 degrees centigrade, then automatically the system will on this cooling fan for providing the coolant for this battery pack. So these are the main features, and parallelly same data will be uploaded to the ThinkSpeak. These are the main features of the project. So to execute the features, we are going to provide the 230 volts AC input to the transformer. So from there, the 12 volts of AC is the output to this regulated power supply board, and it has a mainly 3 stages: rectification to convert the AC to pulsating DC, filtration to remove the pulses and provide us the 12 volts constant DC. The 12 volts constant DC is a supply voltage to the fan and also to this relays to allow the power supply to this battery pack. So means the 12 volts is mainly parallelly input to our battery pack for charging purpose to control the fan also, and output of this 12 volts from the capacitor is input to the 7805 regulator, so which will take 12 volts DC input and provide us the 5 volts constant DC output. So from there, the 5 volts DC is the main operating to our overall microcontroller unit along with the nothing but Arduino UNO board. And once we provide the power supply to this Arduino UNO board, which is the main brain of our system, which is continuously monitor the input output modules along with data uploading to the ThinkSpeak. And in our project, the input modules are, as we discussed, temperature sensor, voltage sensor and current sensor, and these 2 selection switches to on and off this electromagnetic relays. And the output modules are buzzer board, electromagnetic relays, as well as ESP8266 Wi-Fi module to upload the data to the ThinkSpeak, and this is a transistor board to control this fan for the coolant purpose, so which has a BC547 transistor board. So these are all about the components, and let us check with the outputs. So before demonstration, first of all we need to enable the hotspot in your phone. Go to hotspot settings of the phone and configure the hotspot name to project 7353 without any space, without any capital letter. Password should be 123456789 and band should be 2.4 gigahertz. After we enable the hotspot, we can on the power supply to the kit. So we should enable the hotspot along with the data. So once welcome message displayed on the LCD screen, so the buzzer will be on and off 2 times. Then continuously it will measure the voltage and the next current and next temperature, and the next screen SOC SOH values. So SOC SOH values will be calculated after 10 to 15 seconds of duration based on the voltage levels, dropping voltage or maintaining voltage in the battery pack. So you can see the one device is connected in your mobile phone. Now stay on the ThinkSpeak. Okay, so same around 15 seconds of duration, the ThinkSpeak will accept the data. Till the duration we can monitor these parameters, right? You can see the data was calculated on displayed on the LCD screen continuously. So here we are using these switches to on and off the DC motor. So when we on the DC motor on LCD, we can see the power consumption is 1065 milliamps of current was consumed by this one. Okay, and when we off this, so if it's a load occurred on that one, that will be monitored on the LCD screen and that will affect the SOC SOH values. We can observe that. And so if the battery voltage is low, for that purpose we are making use of this switch to make voltage fault. So this is a switch just to isolate the power supply to the voltage sensor, so that the microcontroller will get less than 8 volts. So whenever the voltage is less than 8 volts, then the system will provide us audible alert to the buzzer as indication of low battery voltage. On the LCD message will be displayed. Just we need to select that. Okay, and normal charging will be displayed on the LCD screen here, and fast charging will be displayed on the LCD screen. As you can see, the data is getting uploaded here. So here it's continuously uploading, and whenever the battery voltage is coming to normal, so the relay is automatically off. Means we are going to protect the battery from overcharging. And if due to any reasons the temperature increases, so just I'm using the external heater. On LCD we can see the temperature increases when it crosses 45 degrees centigrade. Then we can see the motor got switched on as to make the cooling of the battery pack. Whenever the battery temperature is less than 45, automatically fan will get switched off. Coming to the ThinkSpeak, so these are data we're continuously getting. Just click on that, we can get the parameters along with the date and time. Here we can download this and we can erase the old data. So to download the data, go to data import export, and in that download the data, and it will get downloaded in Excel sheet, and that will be open in Excel sheet, and that will consist of date and time. So here date and time and number of samples till now we have collected, and field 1 is the voltage and currents, like this the temperature along with the SOC SOH values. Total 5 fields we can get the data. So after we took the backup, now go to channel settings. Only do clear the channel, don't do any other changes. After channel got cleared, now go to private view to access the live data, and channel settings to erase the old data. While scrolling, don't touch on this blue bar. And current, temperature, SOC SOH, total 5 fields values we are going to get for every 15 seconds of duration into the ThinkSpeak. So yeah, right, so just now we got the data, temperature value. Just click on this, so we can get in the data now. So this is the execution process, continuously monitoring temperature and voltage, current and SOC SOH calculations, and that will be monitored on the LCD as well as to the IoT ThinkSpeak. This data can be accessed from anywhere in the world directly. Thank you.